Hello class. So today we're going to continue with logic gates. We're going to look back at OR gates and AND gates just a little bit and look at something new with them called waveforms. So it's kind of like what we did with the truth tables, using the ones and zeros as on and off, but instead of having a truth table, you look at it using a waveform. And a waveform is useful when any type of software engineers or electrical engineers or any type of computer engineers are looking at systems or trying to identify anything that's going on in the system, they look at the waveforms. So remember, logic gates are just types of commands where they control stuff. So when one is on, one is off, and they control what passes through into the output. And so you can look back at the waveform history and see maybe if the system went wrong somewhere. Okay? So remember, the AND gate is A and B, the OR gate, right, as A or B. So that's the very basic example. There is another way to write them, and you will probably like writing them this way a little bit better. For OR gate, instead of writing it like this, for OR gate we use a plus sign. So that means same thing, A or B. Okay, so that's what the plus sign means. Plus sign means OR. And for the AND gate, we write it as you would multiplication. So just like that, you write them together. That means A and B, because they're together. Okay? So if you see them written like this, moving forward, that's all they mean. Alright, so waveforms. What do we mean by waveforms? Okay, so let's look at a waveform of an OR gate. So you have your two inputs, and this represents when X is on, and when the input X is off. And same thing here, whatever Y input is, this is on and off. Okay? This is given by times. This really could be anything. It could just be every time the system is checked or anytime the system changes. So a lot of times it's easier just to put it as time 0, time 1, time 2, and so on. Okay, so here's our inputs at these particular times. So at time 0, they both are off. At time 1, Y input is still off, or 0. But the X input at time 1 changes to on. Okay, so here is 0, 0, here we have 1, 0, X is still on, and now Y has come on. So now we have a 1, 1. So did everybody see that? So just kind of like your truth table. 0, 0, a 1, 0, 1, 1. Here X is still 1, but it goes to off, sorry. So now it's 0. Y is still 1. And at time 4, X is 0 and Y is still 1. So if you were making a truth table, you'd have 0, 0, 1, 0, 1, 1, 0, 1, 0, 1. So what would the output look like? This is an OR gate, so that means X or Y has to be on. So if both of these are off, then the output's going to be off. Okay? Now what about time 1? Off and on. So we have at least one on, so the output's going to come on. Okay, now what about time 2? Well, they're both on, so it's still going to be on. What about time 3? X went off, but Y is still on, so the output's still on. And what about at T4? Y is on, but X is off, so at least one of them's on. So that's the output waveform. Okay, so it's really that simple. So if you understood the truth tables first, then you know how to write the waveforms. Okay. So we're just going to focus on the OR gate today. Next week we'll get into the AND gate. And if you're wondering where this is going, because obviously we are moving at a little bit slower pace than we would in class, there are other gates, and eventually we'll start making logic circuits, intermixing and combining different gates and stuff like that. and then we'll be using algebraic expressions to evaluate those gates. Okay, so that's what's coming up. Maybe next week we'll start looking at combination circuits. Okay, so here's your assignment. You'll turn this in today. So draw the output waveform for a 3-input OR gate. Okay, so it's just like the 2-input we did, but now it's just 3 inputs. So it's still an OR gate, so as long as A or B or C is on, then your input will be on. Okay, so you got 4 times here, start at time 0. So just copy this down. Okay, really you just need to copy down the waveform and show me what the output would be like. Okay, if you have questions, get with me on Teams, make a post or send me a message, and I'll respond as soon as I can. Thanks guys, have a great weekend. See y'all next week.